Hello everyone, this is Keisha here, and in this video, we'll delve into the fascinating phenomena of wave refraction and interference. These concepts are essential in physics and have numerous real-life applications. I hope this video will enhance your understanding and appreciation of wave interactions. Over the next 6 minutes, we'll delve into these interactions, demonstrate them, and discuss their practical uses. For the big question we'll be answering by the end of the video is why might visionary leadership cause and/or affect transformation? First, let's talk about wave refraction. Refraction occurs when a wave changes direction as it passes from one medium to another due to a change in its speed. This phenomenon is commonly observed with light waves but can occur with any type of wave, including sound and water waves. To demonstrate refraction, imagine shining a light through a glass prism. As the light enters the prism, it slows down and bends towards the normal line. Upon exiting the prism, it speeds up and bends away from the normal. This bending of light or refraction can be visually striking, how the laser beam bends as it enters and exits the blocks, illustrating refraction in action. In my example of demonstration here, in a day-to-day life, we always clean our windows by using window cleaner with spray. This spray needs a straw to be able to function. Refraction can be seen here. The straw is bended. Refraction has many practical applications. Eyeglasses and contact lenses correct vision by refracting light to focus properly on the retina. Cameras and microscopes use lenses to refract light and produce clear images. Refraction is also responsible for phenomena such as the bending of a straw in a glass of water or the formation of rainbows, just like the example for my spray. Now, let's move on to wave interference. This occurs when two or more waves meet while traveling through the same medium. The principle of superposition states that the resultant wave is the sum of the displacement of the individual waves at each point in the medium. There are two types of interference, constructive and destructive. In constructive interference, the waves align with matching phases, creating a wave of greater amplitude. In destructive interference, the waves are out of phase and cancel each other out, resulting in a wave of reduced or zero amplitude. We can visualize this with a simple water tank demonstration. When two sets of waves are generated at different points in the tank, they travel and interact with each other. Where the crests of the waves meet, you'll see constructive interference. Where a crest and a true meet, you'll see destructive interference. Wave interference is critical in various technologies. For example, the noise-canceling headphones uses destructive interference to reduce unwanted ambient sounds. In optics, interference patterns are used in instruments like interferometers to measure very small distances and changes with high precision. In summary, wave refraction and interference are key concepts in understanding wave behavior. Refraction occurs when a wave changes direction due to a change in speed when passing from one medium to another, while interference happens when waves overlap and combine. These interactions have practical applications in technology, from eyeglasses and cameras to noise-canceling devices and optical instruments. Interference and refraction can also be seen in other fields such as acoustic. Sound waves, just as light waves, bend when they pass through different media. Sound waves also retract. For instance, sound waves traveling through air will bend when they encounter layers of varying temperature or density, which is why you might hear sounds differently at night when the ground cools down. And for interference in engineering with structural health monitoring, interference patterns are used in methods like holographic interferometry to detect changes or defects in structures. When a structure is stressed or deformed, the interference pattern changes, revealing details about the structural integrity. And so for the answer to the question, visionary leadership causes transformation by redirecting an organization's focus and energy towards new goals. Similar to how refraction changes the wave's direction through different media, it also affects transformation by combining innovative ideas with existing practices, creating constructive interference that amplifies the organization's capabilities. Thank you for listening to my video.